last example of section 3.6 marginals, and I think it's a good one because it connects to what we will talk about next week on demands and elasticity. So they're giving us a demand function, which is a function of price of an item. So think about it. If let's say that you want to buy this new computer, okay? If the computer is $5,000 and you may think it's too expensive, you don't want to buy it anymore, okay? But if a computer has a reasonable price, like let's say $700, let's say, and then you think that's a very good price, then you may change your mind. So depending on the price of an item, the demand will change. And typically, if you think about it, the more expensive things get, people don't want it, right? Like typically, like if a haircut, let's say that I need a haircut, if a haircut is $5,000, I am less likely going to get that haircut. But if a haircut is, let's say, $20, okay, then I may get it. So usually they have inverse relation. Like as price goes up, the demand tends to go down. But that doesn't always apply to like other items, things like gas. Like I need to drive to work, so I always need to buy gas no matter how expensive it is. So for those items, and again, I think I'm talking about the next section, but all right, let's go ahead and just work with this demand function they gave us. So demand D for a new rollerball pen. So we're talking about a pen here. It's given by D equals, so this is a demand function, and P represent the price of this rollerball pen. A says, find the rate of change of quantity with respect to price, dP. So they're asking for the change in demand with respect to price. Okay, as price changes, how will the demand for this rollerball pen change? I need to just take the derivative. So dP, which is just d prime of x, d prime of p, is equal to 0.018 multiplying 6 times 3, and that's 18, p squared minus 0.6p plus 140. So we found the derivative function for this demand. The demand will change according to this. All right, B. How many units will consumers want to buy when the price is $25 per unit? They're asking for the demand. They're not asking for the change in demand, right? They're just asking for what's D? What is the demand when a pen is $25? Oh, wow. Let's plug in 25 into the original function, not the derivative function. I almost got tricked because we just found the derivative, but if you look at the wording of this, they're simply asking for how many units will consumers want to buy. They're asking for demand. So I'm going to plug in 25 into the original function. That sounds like an expensive rollerball pen. Whenever I need a pen, I just ask Aveen or other people in class. Okay, so 0.006 times 25 cubed minus 0.3 times 25 squared plus 140 times 25. So the demand will be 3,406 pence. If it is $25, the demand will be 3,406 pence. All right, how about C? Find the rate of change at P equals 25. Okay, so when the price of a pen is 25, how is the demand changing? Okay, I'm gonna go ahead and plug in 25 into the derivative function. Okay, and that will be 0.018 times 25 squared minus 0.6 times 25 plus 140. Okay, so the number came out to be 136.25 pence per dollar. Now, what does that mean, right? What does that mean? We better talk about this. The interpretation of this would be when a pen goes more expensive, like it gets $1 more expensive, the demand will actually go up by, you know what, since this is talking about a number of pens, I think I will just go ahead and write this as a whole number. Like per additional dollar we charge on this pen, like if the price goes from $25 to $26, the demand will actually increase. That's crazy, because I'm thinking if pen is more expensive, people will less likely to buy it. So the answer to question D, okay, would you expect DP to be positive or negative? You know, I would expect the change in demand per price, per change in price, to be negative, because the more expensive an item is, I was thinking the less likely people will want to buy this. Doesn't that make sense, right? But maybe that's not the case. You know, why do people buy these Gucci's and, you know, all these, you know, name brand stuff? Maybe, I don't know, like when something is more expensive, are we desiring it more? Like, do you want to buy something because it's more expensive? I don't know. This is interesting, because the answer to part C came out to be a positive number. So the demand for this rollerball pen is actually going up as they make their pen more expensive after $25. So they should charge the pen $26. But usually you would expect this to be a negative, because the more expensive things get, the less likely for people to buy it. So I don't know, this is interesting. So I want you guys to try this homework problem. Maybe some of you will get a negative number for part C, but mine was positive, so that got me to think about it a little bit. All right, but that's it for section 3.6. This is interesting, the demand. So we will come back next week and talk more about demand and something called elasticity next week, okay?